The countdown has begun, and the world is holding its breath as SpaceX prepares for another mind-blowing launch that will send a Dragon cargo ship soaring into the cosmos. Mark your calendars. April 21st is the day when a Falcon 9 rocket will thunder off the launch pad, carrying NASA's latest delivery to the International Space Station, ISS. This isn't just another routine mission. It's a high-stakes, adrenaline-pumping journey, packed with cutting-edge science, life-saving supplies, and experiments that could revolutionize space exploration forever. Liftoff is set for 4:15 a.m. Eastern Daylight Time, 08:15 Greenwich Mean Time, from Kennedy Space Center's legendary Pad 39A, the same historic site that launched Apollo missions to the Moon and the Space Shuttle into orbit. Early risers and night owls alike won't want to miss this spectacular pre-dawn fireball as the Falcon 9 rocket ignites the sky with an explosion of light and power, propelling the Dragon spacecraft toward the stars. But what's inside this high-tech cosmic delivery van? NASA isn't just sending up food and water. This Dragon is loaded with groundbreaking experiments that could change the future of space travel. Among the jaw-dropping payloads is a revolutionary air quality monitoring system designed to protect astronauts on future Moon and Mars missions. Imagine, this very technology could be the key to keeping humans alive on the Red Planet. And that's not all. Tucked inside Dragon's pressurized cabin are two ultra-precise atomic clocks set to test Einstein's theory of relativity and the microgravity of space. These clocks could rewrite the rules of timekeeping and synchronize global navigation systems with unprecedented accuracy. If that doesn't send chills down your spine, what will? But wait, there's more. Free-flying robots are also hitching a ride, set to demonstrate next-gen maneuvers that could pave the way for autonomous space repair drones. Picture this: self-piloting robots zipping through the ISS, fixing critical systems without human intervention. The future is here, and it's absolutely terrifying and thrilling. SpaceX's Dragon spacecraft is no stranger to the ISS, having completed dozens of resupply missions with flawless precision. After docking with the station, Dragon will remain in orbit for several months, packed with vital supplies, before making its dramatic return to Earth, plunging through the atmosphere in a fiery descent, before splashing down in the ocean for recovery. But here's the shocking twist: SpaceX isn't the only player in the cosmic cargo game. Northrop Grumman's Cygnus spacecraft was supposed to launch next, but disaster struck when the vehicle was damaged during transport, forcing a delay until later this year. Meanwhile, Russia's Progress spacecraft continues its steady supply runs, but let's be real, nothing beats the sheer spectacle of a SpaceX launch. This mission, dubbed CRS-32, is yet another nail-biting chapter in the saga of human spaceflight. With over 2 tons of cargo hurtling toward the ISS, every second of this launch will be edge-of-your-seat intensity. Will the Falcon 9 stick its landing? Will the experiments unlock new secrets of the universe? One thing's for sure, you won't want to look away. So set your alarms, grab your coffee, and prepare to witness history in the making. Because when that rocket ignites, it's not just a launch, it's a giant leap toward humanity's future among the stars. The countdown is on. The stakes are high. The world is watching. Will you be there when the sky erupts with the fire of progress? The anticipation is reaching a fever pitch as SpaceX gears up for yet another heart-stopping, spine-tingling launch. One that will send a state-of-the-art Dragon cargo ship roaring into the heavens, delivering NASA's most critical payloads to the International Space Station. This isn't just another supply run, it's a high-octane, pulse-pounding mission, packed with cutting-edge tech, mind-bending experiments, and the very future of human spaceflight hanging in the balance. As the Falcon 9 rocket ignites its engines, the sheer force of its thrust will shake the ground, rattling bones and sending shockwaves through the pre-dawn darkness. The blinding fireball will light up the Florida coastline, a breathtaking spectacle visible for miles. A reminder that humanity is still pushing the boundaries of the impossible. And when Dragon separates from its rocket, it will embark on a high-speed chase to rendezvous with the ISS, where astronauts eagerly await its precious cargo. But what makes this mission so explosive, so unmissable? Hidden within Dragon's unassuming exterior are game-changing innovations that could redefine space travel. Among them is a brand-new plant growth experiment designed to test how crops thrive in microgravity. Why does this matter? Because if we're ever going to colonize Mars, we'll need to grow food in space. And this experiment could be the first step towards self-sustaining space farms. Then there's the advanced biomedical research packed aboard. Scientists are sending up human tissue chips to study how zero gravity affects organs at a cellular level. The implications? Revolutionary breakthroughs in long-duration space health, potentially unlocking secrets to combating muscle atrophy and bone loss, problems that could make or break future deep space missions. And let's talk about the high-risk, high-reward tech demo flying on this mission. A next-gen laser communication system. If successful, it could turbocharge data transmission between Earth and spacecraft, delivering ultra-high-definition video feeds and real-time science data at speeds never before seen. Imagine watching a Mars rover's discoveries live in crystal clarity. This is the tech that could make it happen. But the drama doesn't stop there. SpaceX's Falcon 9 booster will attempt yet another daring landing, a white-knuckle descent back to Earth, where it will either stick the touchdown or go up in flames. Every recovery is a nail-biting spectacle, proving that reusable rockets aren't just sci-fi, they're the present. Meanwhile, aboard the ISS, astronauts are preparing for Dragon's arrival with military precision. The station's robotic arm will snatch the spacecraft out of orbit, guiding it to a secure docking. One wrong move and catastrophe looms. But with SpaceX's track record, expectations are sky high. And here's the kicker. This launch is just the beginning. With NASA's Artemis moon missions and eventual Mars ambitions on the horizon, every Dragon flight is a critical stepping stone toward an interplanetary future. The science delivered now could save lives tomorrow, protect astronauts from deadly cosmic radiation, and even pave the way for the first off-world colonies. So as the clock ticks down to April the 21st, the world waits with bated breath. Will this launch go off without a hitch? Will the experiments deliver groundbreaking results? One thing's certain. When that rocket blasts into the void, it's not just carrying supplies. It's carrying humanity's dreams. The sky will burn. The future will be written. And you'll want to be watching when it happens. The clock is ticking down to what could be SpaceX's most consequential cargo mission yet. On April 21st, as most of the world sleeps, a thunderous roar will shatter the pre-dawn silence over Florida's space coast. The Falcon 9's 9 Merlin engines will ignite with the force of a small earthquake. Their combined 1.7 million pounds of thrust, catapulting the Dragon spacecraft toward the stars in a spectacle of fire and fury that will turn night into day. This isn't just another resupply run. It's a carefully choreographed orbital ballet where milliseconds matter, and the margin for error is razor thin. Hidden within Dragon's pressurized cabin lies a payload so sensitive it could revolutionize how we explore the solar system. NASA's new Express Rack 11 is a cutting-edge microgravity laboratory that will enable astronauts to conduct experiments we can't even perform on Earth. Imagine running physics experiments where gravity isn't a factor, or growing perfect protein crystals that could lead to breakthrough medications. This single rack represents the future of orbital research, a plug-and-play science hub that can support up to 10 different investigations simultaneously. But the real showstopper might be what's riding in Dragon's unpressurized trunk. The Space Test Program's STPH-9 payload contains experiments that sound like science fiction, self-healing materials that repair themselves in orbit, advanced radiation shielding that could protect Mars-bound astronauts, and a revolutionary new atomic clock that's 50 times more stable than current space clocks. This isn't just equipment. It's the technological foundation for humanity's future as a multi-planet species. The launch itself will be a masterclass in precision engineering. At precisely T plus 2 minutes, 33 seconds, the Falcon 9's first stage will separate with explosive force, beginning its daring descent back to Earth, while the second stage continues the journey to orbit. Meanwhile, Dragon will face its own trial by fire, literally. As it pierces through the upper atmosphere, the capsule's heat shield must withstand temperatures hot enough to melt steel, all while maintaining perfect trajectory to meet the ISS. What makes this mission particularly nerve-wracking is the tight launch window. The ISS orbits Earth every 90 minutes at 17,500 miles per hour, meaning Dragon has just seconds to achieve perfect insertion or risk missing its rendezvous entirely. NASA's trajectory specialists have calculated the exact moment when Earth's rotation will position pad 39A perfectly for this orbital dance. Miss that instant, and the entire mission could be delayed for days. As Dragon approaches the station, the real test begins. The spacecraft must navigate within inches of the massive orbital outpost, using nothing but its Draco thrusters and onboard computers. One wrong calculation could mean disaster, but SpaceX's autonomous docking system has proven itself time and again. When that final soft capture signal lights up in mission control, it will mark the culmination of years of engineering brilliance condensed into a single, perfect moment. This launch represents more than just another cargo delivery. It's a testament to human ingenuity, a demonstration of what's possible when we dare to push boundaries. The technologies riding on this Dragon could shape space exploration for decades to come. From advanced life support systems to revolutionary propulsion experiments. When those engines light, on April 21st, they're not just launching a spacecraft, they're igniting the future. The tension is palpable as SpaceX prepares to make history once again. This Dragon mission carries something unprecedented, a suite of artificial intelligence systems that will completely transform how astronauts interact with their spacecraft. These aren't just simple voice assistants. We're talking about advanced neural networks capable of predicting equipment failures before they happen, optimizing life support systems in real time, and even assisting with complex scientific experiments. The implications are staggering. Imagine an AI co-pilot that learns each astronaut's work patterns and can anticipate their needs in an emergency. But the real game changer might be what's not listed on the official manifest. Industry insiders whisper about a classified DARPA payload hidden among the routine supplies, an experimental propulsion component that could lead to radical new space travel technologies. While details remain shrouded in secrecy, leaked documents suggest this could be the first step toward propulsion systems that would make Mars transit times dramatically shorter. The very future of interplanetary travel might be tucked away in Dragon's cargo hold. The timing of this launch couldn't be more critical. With the ISS entering its final years of operation, every resupply mission now carries extra significance. The station's aging systems require increasingly sophisticated maintenance, and this Dragon is packed with specialized tools and replacement parts that simply can't fail. Among them, a next-generation carbon dioxide scrubber that uses revolutionary nanomaterials to clean the air more efficiently than ever before. This isn't just about keeping astronauts alive today, it's about perfecting the technology that will sustain lunar bases tomorrow. Weather remains the wild card that could throw everything into chaos. April in Florida means unpredictable conditions. One moment clear skies, the next moment thunderstorms rolling in off the Atlantic. SpaceX's launch meteorologists are monitoring developing weather patterns with military precision. Knowing their forecast could mean the difference between a flawless launch and an expensive scrub. The team has just a 30-second window each day when Earth's rotation perfectly aligns with the ISS orbit. Miss it, and the whole operation gets pushed back. Down in the payload processing facility, engineers are making final adjustments to what might be the mission's most delicate cargo, a collection of stem cells that will be grown in microgravity. Previous experiments have shown that space-grown stem cells develop differently than their Earth-bound counterparts, potentially leading to breakthrough treatments for everything from spinal cord injuries to heart disease. These cells are so sensitive they're being kept in a special biocontainer that maintains perfect conditions down to a fraction of a degree. As launch day approaches, all eyes are on the rocket's second stage, the unsung hero that must perform flawlessly to deliver Dragon to its precise orbital insertion point. SpaceX has implemented new upgrades to this critical component, including enhanced thermal protection and more powerful thrusters. The modifications haven't been fully tested in operational conditions, adding an extra layer of suspense to an already high-stakes mission. The world may see this as just another routine cargo launch, but those in the know understand the truth. Every one of these missions writes another paragraph in the story of human space exploration. When those engines ignite on April 21st, they're not just lifting supplies to orbit. They're carrying the hopes, dreams, and future of an entire species reaching for the stars. The countdown has begun, and history waits for no one. The stakes have never been higher as SpaceX's Dragon spacecraft prepares to deliver a payload that could fundamentally alter humanity's relationship with space. Tucked among the usual supplies is a revolutionary 3D bioprinter capable of manufacturing human tissue in microgravity, an innovation that could lead to printing entire organs in space. Scientists believe the weightless environment allows for more precise cellular structures, potentially solving Earth's organ donor crisis. This isn't science fiction, it's happening now, and the results could save millions of lives. A little known But critical component of this mission involves testing new quantum communication technology. Unlike traditional radio systems, these quantum encrypted signals are theoretically unhackable and could provide the foundation for a secure interplanetary internet as we expand into the solar system. The implications are profound. Imagine astronauts on Mars video calling Earth with zero lag, or mission control sending complex instructions instantly across hundreds of millions of miles without signal degradation. The Dragon's unpressurized trunk carries an experimental debris capture system that could solve the growing threat of space junk. Using advanced polymers and electromagnetic fields, this prototype device will test methods of safely deorbiting dangerous fragments that threaten satellites and spacecraft. With over 100 million pieces of debris currently orbiting Earth, some traveling at 17,500 miles per hour, this technology could literally save the space economy from catastrophic collisions. Perhaps most intriguing is the inclusion of microbial samples collected from some of Earth's most extreme environments: deep-sea hydrothermal vents, Antarctic ice sheets, and even Chernobyl's reactor core. Scientists want to study how these ultra-resilient organisms adapt to space conditions, potentially revealing clues about the origins of life and how it might survive on other worlds. The results could reshape our understanding of where life might exist in our solar system and beyond. The launch itself will showcase SpaceX's latest rocket upgrades, including a new thermal protection system for the Falcon 9's first stage that allows for faster turnaround between missions. These modifications, developed using data from previous launches, demonstrate how SpaceX continues to push the boundaries of reusability. The company's engineers have also implemented AI-driven pre-launch checks that can detect potential issues humans might miss, adding another layer of safety to an already rigorous process. As the spacecraft approaches the ISS, it will conduct an unprecedented maneuver, testing a new automated docking protocol that uses machine learning to adapt to unexpected situations in real time. This system, trained on thousands of simulated docking scenarios, could eventually allow spacecraft to dock autonomously at distant locations like lunar orbit or Mars, where communication delays make remote control impossible. The psychological impact of this mission shouldn't be underestimated either. Among the cargo is a carefully curated selection of fresh foods and personal items requested by the astronauts, small comforts that maintain crew morale during long months in space. These seemingly trivial items play a vital role in mission success, reminding us that behind all the advanced technology, human beings remain at the heart of space exploration. Every component of this mission, from the groundbreaking science to the routine supplies, represents another step in humanity's journey to becoming a spacefaring civilization. When Dragon separates from its Falcon 9 rocket and begins its solo journey to the ISS, it carries with it not just cargo, but the collective aspirations of everyone who dreams of a future among the stars. The countdown clock continues its inexorable march toward liftoff, and with each passing second, we move closer to rewriting what's possible. The April 21st launch represents a quantum leap in commercial space capabilities, carrying a first-of-its-kind commercial airlock module that will dramatically expand the ISS's capacity to deploy satellites and experiments directly from the station. This innovative system, developed by a private aerospace startup, features a robotic arm and deployment mechanism that can handle payloads up to the size of a refrigerator, opening new revenue streams for NASA's commercialization efforts while giving smaller companies access to space. Tucked away in a specially designed compartment is an experiment that could change space agriculture forever. A closed-loop ecosystem containing genetically modified plants, engineered for maximum nutrient production in microgravity. These superplants grow 30% faster than normal varieties and require minimal water, potentially solving one of the biggest challenges for long-duration missions. Scientists will monitor how their specialized root systems adapt to space conditions, data that could prove invaluable for future Moon and Mars colonies. The mission will debut a revolutionary new power system for Dragon, ultra-lightweight solar panels with 40% greater efficiency than current models, incorporating technology originally developed for NASA's upcoming lunar space station. These panels fold out like origami and can self-repair minor micrometeorite damage, representing a giant leap forward in spacecraft power generation. SpaceX plans to implement this technology across its entire fleet in coming years. Perhaps most groundbreaking is the inclusion of a prototype quantum sensor array that can detect minute changes in gravitational forces. This instrument, about the size of a shoebox, could lead to navigation systems so precise they don't require GPS satellites. Imagine spacecraft that can determine their exact position in space by measuring subtle variations in gravity fields. The military implications alone have defense experts buzzing with anticipation. The launch will also test a new emergency abort protocol developed after lessons learned from previous missions. During ascent, Dragon will maintain the ability to separate from the Falcon 9 at any moment and execute a precision landing using upgraded parachutes and thrusters. These improvements could someday allow cargo missions to be recovered safely even during launch failures, a capability previously reserved only for crewed flights. Hidden among the more publicized experiments is a suite of radiation shielding materials being tested for NASA's upcoming Mars missions. These innovative composites, some incorporating nanomaterials and magnetic fields, could reduce astronauts' radiation exposure by up to 60% compared to current shielding, potentially making the difference between life and death on interplanetary journeys. As the world watches the April 21st launch, few will realize they're witnessing the quiet debut of technologies that may one day enable hotels in orbit, mining operations on asteroids, and permanent settlements on other worlds. Each component aboard this Dragon spacecraft represents another piece of the puzzle in humanity's greatest adventure, the journey to become an interplanetary species.